Some examples of SPIs, the obvious ones are acts dangerously, but that's only one piece of SPIs. Sure, getting too close to pedestrians is an issue. Tailgating another vehicle is clearly an issue. But you'll only know about those happening after you deploy if they're really rare events that are not seen in testing. The components also have SPIs they can meet. You can have false negative and false positive detection rates. Your safety argument is built on some sort of claim about how good your sensors are and how good your perception is. And if your perception is not as good as you think it is, then probably you're not as safe as you think you are. Correlated multi-sensor failure rates are going to be a sticking point here, because the assumption if you have 3 sensors, at least one will see something, might be violated in some rare cases, but often enough to be a problem. If, however, you have SPIs on each type of sensor, you can do things like, say, in this picture, there's a system which did not see the child next to the parent. If you wait for lagging metrics, that may not be good enough, because the lagging metric is, did you almost hit a kid but you stopped in time? You don't really want to wait for that to happen to realize you're never seeing a kid next to an adult. So the SPIs down at the lower level that get into more granularity about system performance are going to help here. They're going to tell you have a problem before you get a near hit incident. If your sensors are getting dirty and they're not getting cleaned, then you need to know that before the dirty sensor causes a mishap. The idea of a SPI is, if it's relevant to safety, it should be in the safety case. And if it's a claim in the safety case, if at all possible, you should be measuring it with a SPI.